In the previous session, we were looking at how to visualize the data. We are going one step ahead today. All right. So our goal is to see that how, if we have a proper data set available, right, what we can do with that, or how we can obtain what is called as a clear insight of the data, whatever. Okay, so this is called as exploratory data analysis, which is one very important part of our machine learning, deep learning, data science journey. Right. So because of that, it's not sufficient that if you have a huge data set and you know what is in it. Some of the cases we have seen in some of the cases that even though you know what is in the data, I know that it's a temperature data. It consists of the weather details of a particular location at various time, right? But you may not know, do I really need that much of data in order to build an application out of it? So it's absolutely necessary that you need to have an insight of your data set. So obtaining the insight of your data set after you perform what is called as a pre-processing is very important. So this is what we are going to discuss today mainly. And that part is what is called as the EDA, which is the exploratory data analysis. All right. So what are the objectives for today? You can see that first we need to understand the requirement of why do you need a clean data set. So I may have a data set corrected in the raw format. There will be missing numbers, right? Some unwanted characters, etc. Many things will be there. So what we want is that we need to know that why do I clean that, right? Why should I clean that? If I don't clean, what happens? This is what we are going to see today initially. So after that, we'll be looking at how you can use the various libraries that we have been learning so far, maybe in the past 10 days or something, right? So they are pandas, numpy, matplotlib, how to perform the pre-processing, use that, and derive the meaningful insight. So this is absolutely necessary. I should know that what do I mean by the meaningful insight. So this is something like insight we will be always having. So we'll be knowing that what is there in my data. But meaningful, how to get the meaningful insight of the data, right? We'll be taking up a very practical data. We'll be collecting that and we'll be using that data, we'll be using that data and we will see that how to have a, right, how to have a beautiful visualization, how to have a beautiful insight of that data. So this is what is our fundamental idea today. And let us see, right, what else we can do, how else we can go ahead. So those who are going to work along with me, I'll try to share the data set. Okay, so just see, I'll add the data set directly to the chat box so that you can download and you can keep it ready. Even if you may not work right now, right? At a later stage, if you want to work, this is going to help you out. Okay, so let's say, just give me 1 second. I'll add the. All right, so you can see a CSV file that gets loaded into the chat box. You can download that from your site and you can save it in your computer. That is the data set. Now let's look at the data set. You can see that the data set is actually a Play Store data set. So we already have an idea what is a Play Store. So from the Play Store, you can download you can actually explore what are the various apps that are available. Also, you can search for apps. There are various categories and you can download that. If you don't like it, you can remove that, right? You can write a comment about that. You can write a review, etc. Many things you can do, right? So this is a Google Play Store data set. What exactly you have? There are 10,841 various types of apps. 10,841 apps are there. Okay, so that's the first thing. And among that, so you see that the number of rows in your data set is 10,841. And each record, in a sense, if you consider a particular row, there are 13 columns. In a sense, there are 13 features available for each of the app. So what are the different features, right? You can say that what is the app, which category it belongs to, what is the rating, how many reviews are there, what is the size, how many installs are there, what type it is, what's the price, if it is free or paid. If it is paid, you'll mention that this is the price of this. What's the rating, right? Which genre it is, and when this app was recently last updated, okay, which is the current version, and you can also see that which Android version it is supporting. So this is a practical data. Now you see that. What do you mean by the practical data? Whenever you collect, again, this is not the actual size of data which you may encounter when you are dealing with the data science or machine learning problem, but definitely this is going to introduce you to the real world. All right. So this let's try to look at the problem definition. What we are trying to do here today, we are not trying to build any machine learning model, deep learning, or any. We are not trying to solve a data science related objective here, but you can consider that you are trying to perform the data analysis. We have a data set, we have collected a data set, and our intention is to have a beautiful insight of that. So as you can see, if you read this, you will understand that we have collected the raw data set. Whatever is present over there, it's in the raw format. But whenever we want to do a particular modeling of this data, this has to be in a structured format. A proper format is required. How can I say that this is not in the structured format? How can I say that, right? This is a raw format. I'm coming to that at a later stage. All right. So we want to have an insight of that. That's the first thing. We want to do pre-processing, cleaning, etc. before that. So what I do, I'll directly import the required packages over here. You can see, and NumPy has been imported. Seaborn, Pandas, Matplotlib, etc. have been incorporated. And I'm saying that plot me in line. So and now you can see, I think you can recognize this particular function pt.readCSV, because our data set is a CSV format. It's as I already have shared it with you. So it's a Google Play Store data, right? So you should be in a position to understand what we are trying to do. Top 10 we are trying to display here. All right. So you can see that. So 0 to 1, 2, 3, 4, etc. The numbers are given, right? Then, right, what is the app name? Which category it belongs to? What is the rating? How many reviews are there? What's the size? So 19M stand for 19 MB. So how many installs you have? Okay. What's up? Which type it is? Free, paid, etc. Price, since it is free, it will be 0. Okay. Then content rating, is it for everyone? Only teens can view, because there will be definitely many categories. Content rating actually talks about that. Then which genre it is, when it was last updated, what's the most current version number, and which Android version number it actually supports. All right, so that is the data which we have with us. So now you see that, okay, this is how the data set is arranged and how many data points you have, right? We'll try to explore that now. You see, I'll call the second function, that is info. So if you remember info, it actually talks about the complete data types as well. So unnamed, that's actually the first this thing, unnamed, right? You can see that 0, 1, 2, 3, it's a numerical data type. So it is int 64. Then, right, wherever you see other formats, there are objects present. There is a floating value present. That's a rating part. It's definitely a floating number. Then the rest of the various features are actually objects. All right. So I understand that, right? This is the data set which I have, and there are 10,841 entries. So starting from 0 to this number, right? So everything is visible if you go for the info part, right? So if you remember, this is the Play Store data is the data frame name which I have given. Okay, right? Let's proceed further. I check the size. It's pretty straightforward. I ask for a describe. You know that only numerical columns will be shown here with the What's the count? What's the mean, variance, standard deviation, minimum, 25, 50, etc. Many values are visible here. If you want to have a statistical look at the data set of whichever columns are numerical, right? We can see that, right? So try to recall. I'll go a bit faster over here. Okay. Now, if I say this is a new thing to you, if I say describe and include all, this was we have not seen so far. If so, I just don't want to go with the describe part. I want to go with the complete thing. What is a complete thing? Complete thing doesn't show me every column. You can say that include all. So, but when you say include all, this is going to show everything. But you see, right? Most of the values will be something like not a numbers because they are not numbers there. There may be text, right? So in such cases, you will see that those quantities will have not a number, not a number, not a number. So only those columns which are completely filled will be on the two columns. One is right, the unnamed. Again, in that case, also unique top frequency, etc., will become not a number. That's obvious. Okay, so let's slightly deviate from this data set and let's look at the statistical version, whatever we are intended to learn in the first part. Okay, so let's start with this. So you can see here there is what is called as a descriptive statistics. Descriptive statistics basically tries to measure various quantities from your data set and tries to explain what happened in your data set. I observe something in my data set and I should be in a position to describe what happened in the data set. So what are the various features that you can extract? What are the various descriptive statistical parameters that you can extract from the data? Right? If you see here, first one is called as a central tendency. Second one is a dispersion. Third one is a skewness. Fourth one is a kurtosis. Again, you might have already studied this in the engineering mathematics, right? Whenever you studied the probability and the statistics chapter. But let's try to go through this very quickly because these are the parameters which we will be using in the session at a later stage. All right. So what do you mean by the central tendency? It's calculating the mean, medians, and mode. So three things you are going to calculate under this. Any of them you calculate, it's a central tendency. Then we have a dispersion, which includes the variance, standard deviation, range, IQR, interquartile range, etc. Then we also have a skewness, that's a symmetry of the data, whether the data is symmetrically present around a central value called mean. We are trying to define that. Then the peakedness of the data mean value. At the data peak, do you have a very sharp corner like this, or do you have something like this? Right. So what is the type of the peak that you see, right, whenever you observe a data? So these are the various parameters. And these parameters will help us in identifying the various descriptive statistical features. In other words, you can do the statistical analysis because of this. All right, so let's do one thing. Now let's start with the concepts one by one. And the first thing is that it's called as a central tendency. So as you know, measures the central tendency of the data. In a sense, you can try to say that what happens to the mean of your data set? How is it, right? You can see that. So the mean actually calculated, if you see, it's a sum of all the values divided by the number of data points. We have given an example. There are so many numbers here. If you remember, if you want to calculate the mean of that, take the sum, divide by the number of elements. So that comes to be 15 here. So that's the first example. And the first type of the central tendency, which is called as a mean. Okay. Then you have the second tendency called as a median. So what do you mean by median? Right? We just have to arrange them in the ascending order, go to the central one. So this is the arrangement in the ascending order, go to the central one. So midpoint is 36. Okay, and another example, you have this as our data set. Try to arrange this in the ascending order. Now you see there is no midpoint because 4 are on the left side, 4 are on the right side. So how do you find out the midpoint here? So in such cases, you can take the average of the central two values. Okay, that gives us 16.5. Then let's move further. The next central tendency commonly used in statistics is called as a mode, right? So this is something like whichever number that repeats very often in your whole data set is called as a mode. So in this, 48 repeats 2 times. That's the only one which repeats highest number of times. So we call that as uh, the mode of our data. So how do you find the same thing? If I have a data set, how do you find out the mean, median, and mode of our data set? Now you see, I'll go ahead with the rating part of our data set. It's a particular column. So let's quickly go back and check what we are talking about. See the rating part. So, okay, not that. Let me go here. So if you look at this particular column, right, that is called as a rating column. You have all the numbers in that, right? So corresponding to each of the app that is present over there, there is a column called as rating. Now I'm trying to calculate the rating, it's mean. So Play Store data, right, of rating, get me the mean. So you see the mean values, right? Get the median. You see the median value, get the mode, you get the mode value. So they are, though they are not same, they are somewhat very close. Okay, that's the first part. Then we'll go for the second second part of the analysis, which is called as a dispersion. So dispersion, right? If you look at the types of dispersion that we are going to measure, right? So it's a second part. You can go with the variance, standard deviation, range, interquartile range. So let's try to look at that. So dispersion, first part is a variance. In mathematics, you will be using the same equation to do the calculation. If you take a square root of this equation, right, you will get what is called as a standard deviation. So that's actually a simple root of our variance. Okay, so root of variance is standard deviation. That's also a type one, right? And normally it is observed that if the 99.7% of the values are always within the 3 standard deviations. So see, this is one standard deviation, this is the second standard deviation, third standard deviation. So around your mean value that is at the center. So let's assume that this is the mean value. So on both sides of the mean value, whatever mean value it is, if you say 3 sigma, sigma is the 3 times the standard deviation, 99% of the time your data point lies over there. Any data that you take, it may look like my data set has a wide range of values starting from say minus 10,000 to plus 10,000. Take a mean of that, it's just the center. So from that center, within the 3 times the sigma value, you have your data set present within that always. Okay, all right. So that should be straightforward. Let's move to the next part. It says that range, right? Range is nothing but where your maximum data point it is and what the minimum data point it is. So the difference is called as the range. Very straightforward formula. Okay, and then we'll move ahead and we have what is called as the interquartile range. That is very important. IQR. So IQR basically talks about the difference between the third quartile denoted by Q3 and the first quartile denoted by Q1. So what do you mean by these quartile? Let's look at an example to understand that. So you see, arrange your data set in the increasing format, 45, 47, 52, 52, 53, 55, up to the last number, which is 80, right? Don't neglect if a value repeats, such as you can see 52 repeats twice, but still we have kept. Okay. The next part. What I do, first I'll go for the median value. Calculate its median value that comes at the center. So now if you see what happens at the center, so that's the midpoint. 53 and 55 we have. So the mean of that will be 54. So median of this data set is 54. I need to calculate this first. Then take a quarter. So take the 50% data. So 50% data, this is the central point. Whatever you have on the left side is the lower half. Whatever you have on the right side is the upper half. So calculate whatever is the midpoint of that. So in this case, it is for 52 for the left half and the 58 for the upper half. So call Q1, this is called as a quartile. 25% of my data set is below 52. And the third quartile says that it is, right, in this case, 58. So remaining, so on the left hand side of Q1, I have 25%. So Q1 to Q3, I have 50%. Then Q3 to Q3 onwards, you have remaining 25%. So that is what is the meaning. So quartile is 25. So Q1, you can see Q1 is written here. Q2 is not written, Q3 is written because Q2 is actually at the center. So that's a Q2, Q1, Q2, 25%, next to 25%, third 25%, and the last 25%. So 25% here, 25% here, then the 25%, and the last 25, totally 100% of my data set is what we can see here. So arranging it in this order itself is the finding out what is a quartile. Now, interquartile range is nothing but it is a difference between the Q3 value and the Q2 value. How much you get? Q3 minus Q1, 58 minus 52, that is equal to 6. So IQR, if somebody asks what is the interquartile range of this data, your answer should be 6. So how do you do the calculation? You have seen it. All right, next let's move further. Let's see how to measure all these. The first part is to go with the variance. Again, I'm calculating the variance of the rating column in our data set. So take any data set, and if you see that, okay, there is a column like this and the whole column contains numerical values, definitely you can apply variance or standard deviation, etc., as and when required. Okay, so that is the variance, then the standard deviation, then we also have the quantile. Like this, in the quantile, if I say 25%, 50%, and 75%, in the result also you'll see the same thing. This is the 25% data, this is the 50% data, this is the 75% of it. Okay. Yeah, so let's move further. Then we have a skewness coming into picture, as we have seen in the definition part of the skewness. You are trying to measure how symmetric is the data around the center. So look at the graph at the center of this. You can see the mid value is the mean. Around the mean, it is symmetric. Okay, but on the left hand side, right, this data is said to have a skewness present. This data is also said to have a skewness present. Okay, so we'll try to measure a skewness value from our whatever points we have. We will apply the skewness function to that. And as and when you get a skewness function's value, you'll be able to identify what is happening with the data over there. Okay, so let's see that if at all value is minus 5 to plus, sorry, minus 0.5 to plus 0.5. What do you mean by that? It means slight skewness is present. If there is no skewness present, 0. So if you have moderately skewed functions, it should be 0.56 to 1. And if it is minus 1 or plus 1 or beyond that, then that is said to be highly skewed graph. Okay, let's move to the next one, that is called as a kurtosis. So what is a kurtosis? If you remember the kurtosis part, so kurtosis basically performs what is called as the peakedness of your data, right? Yeah. So is it flat on the top? So my graph is like this. What happens at the topmost point? Is it a single point or is it a flatted? So that's what we are trying to identify here. So you have a function to do that. And if the kurtosis becomes equal to 0, as you can see here, right? That's very normal. Normal distribution, if you see that, this is equal to that. Kurtosis is negative means, right? This is the peakedness is lesser than, there is no peak, less peak, in the sense more flat. Okay. And if you see the kurtosis is positive, right? This peakedness of graph is more than normal distribution. So you may have normally somewhat like this. So if it is completely flat, this is kurtosis being negative. If it is like this, right? You can see very sharp peak, then you call that as that is supposed to have a more peaked plot compared to the normal distribution. Okay, so just see the examples over here. So what are the various names for them? K equal to 3, it's called as mesocortic. Then platycortic, K greater than 3, K less than 3 is said to be leptocortic. Anyway, the terminologies we are not going to use, but I expect you to know what are the 3 different types, okay, of kurtosis values that you might get. Now, the function to visualize that is whichever column you want to see and whichever whatever is the kurtosis value that comes up, you can see there. Now you can understand this. So the kurtosis value is 65. So 65 means it is positive, it is larger, and right, it is a normal distribution. Okay, so we understood the various aspects in terms of various parameters that you can extract. Okay, that will help us in descriptive analysis or descriptive, descriptive analysis of the data. Okay, now let's go to the, let's try to form some questions. Okay, there are some already formed questions, and even the answers I already have written just to save the time. So what we can do here, we'll just read a question. We'll try to write, we'll try to see what has been written over there and how that is executing what has been asked. So the first part is that check whether there are any null values. Do you have any null values present in your data set? In the sense, it's not very specific saying that any specific column you have to check or any specific row you have to check. It is not mentioned over there. So what you will do, you will simply try to find out not a number is going to exist or not. So already there is a hint present, but I don't think we need a hint because we already have tried pandas. We did 3 or 4 what do you call as assignments, right, in under the panda. So now you should be able to in a position to guess what I'm supposed to do as soon as I read a question, right? So this is what is expected now. So the first question, check whether there are any null values. Okay, do you have any null values? You need to check. So second question is that, is there any duplicate of a record? There is a name for a given app. Something else is there for the same app, right? At a different position, you need to check. Okay. If it is there, how do you handle that is the question, right? You may have to write a code to handle that. So there is a hint saying that drop the duplicates. There is something, if you click on that, it will go to a help section of the pandas wherein you can actually drop something. A particular column or row value you can drop. You can check that at a later stage. But anyway, we'll be using that in the as a solution part in this particular data set. Okay. Then next question says that, are there any non-English app? How do you filter them? So if I say that, okay, first objective, I'll take my data set and I'll completely scan for it so that I may be able to visualize which are the English app and which are the non-English app. Now you need to write a code. So in a sense, it's going to be a Python code wherein you will try to filter them out. So either you should show that okay, so there are say 300 non-English app and these are the non-English app. You have to show them like that. Otherwise, the second option should be you have to remove the non-English app and show the remaining app. So both are same. You can say that you are filtering them out. Okay. Next, you see the next part of the question says that in the size column, multiply, right? This is 10 lakhs for entries having million and multiply 1000 if they have written K, right? So because 10K means 10,000 rupees. So that 1000 should be replaced like this so that if you have a K over there, you should replace that by 1000. Okay, right, etc. So if you have a M present over there, M written over there, you need to replace it by say 10 lakh. So this is the fundamental objective. So I'll try to answer the questions one by one. The first part is that I'll just try to see there is a function called as is_NA. Is not a number, right? So Play Store data is the name of the data frame, right? Then I say that dot is_NA, and I just don't want to get an answer yes or no for all the 10,000 data. That's why the next part is dot sum, right? So it sums it up according to the category and it throws you the answer. It shows you the answer. So I can understand that in the rating column, we have 1474 not numbers. And we can also see in type, I have one not a number. In content rating, we have one number. So Android version, also we have three different values which are right, not a numbers. Okay, so let's say I'll just call this is the one single command which actually eliminates or removes the drop NA, removes the not a numbers. So drop NA, we are very familiar. And I say that in place equal to 2 in the sense I don't want to make another copy of this data frame. Simply inside the data frame, then you remove wherever you find the not a numbers. Next part is how do you find out the duplicate, right? So I'll try to find out, right, the set. What do you mean by set? If you remember the concept of set creates a list containing only one repetition of one item, right? One item can come in a set only once. So if you create that, you have these many entries in the set. But if you look at the Play Store data, this actually has 9360. So the difference between these two numbers, right, are the number of duplicate entries. Okay, remember set is the very helpful tool to do this particular objective, right? Now I'll say that if at all, so in order to remove the duplicate, we have to use a drop duplicates function. I just have to say that drop the duplicates from this particular column called as app, and in that, if I have say 1, 2, 3, three different 3 is a number of times a app is repeated in my data set. I can say that whenever you drop the duplicates, keep the first one. There's no specific meaning for that. Even you can say keep the last one. In a sense, out of the 3, if you select the first one, only the first of the 3 occurrences will be kept, other 2 will be removed. If you keep it last, only the last occurrence will be kept, others will be removed. Okay, so whatever you prefer, you can do that. Then now you check after doing all this, check that whether there are any of the null values, not a numbers exist. Now you see it says 0, 0, 0. Okay, so that's one part. And moving ahead, I just check the data types. I can see that integer is this, object is there, and the float is there. Right. So if you remember the next question, that was find out what are the various non-English apps. So how do you identify whether what you call an app which is available in the Play Store is English or not? How do you identify? Right. Well, first thing is that by just looking at the name. So if at all I try to write an app that is built for Kannada, right? So the name will also be in Kannada. I'll type the Kannada characters as a name. So that's the obvious sense. So right now we are using only that approach. Maybe there are other versions which people say that, right? Maybe this is also an alternative approach to identify whether the app is right English or not. So in this scenario, in order to identify whether an app is English or not, I'll just write a function that actually says that whether the name, if I pass the name of an app to this function, the function should be capable of saying that whether it is an English name present or not. So how do you identify that? What is the logic? I'll just give, say, 30 seconds for you to think. Just think about it, right? What should be the logic? Again, if you refer the internet or maybe any other standard textbooks, each of them will tell a unique approach to finding out whether a word written or a sentence written is English or not. So one of the technique is to use the Unicode. What is a Unicode? It's actually called as a universal code. That code is written specifically for each and every language, each and every character that is present in each and every language. For example, if you take Kannada, right? Kannada K is made up of K plus A. So K has a Unicode. A has a Unicode. So Q plus R gets another Unicode whenever my mobile phone sees that, okay, I'm typing K, it identifies in the form of a Unicode. So that actually helps us in identifying which language you are trying to use. It may be typing, it may be voice recognition, speech recognition, natural language processing, right? Any application you try to build, this is the fundamental approach that one can use. It is very easy. Now, you see that. So I can try to calculate the Unicode of a character by using the ORD function. Okay, so odd of a character means it tells that whether it is, what is the Unicode of that. If you see, if it is greater than 127, it means it is not an English character. Okay, so what we try to do, as soon as I observe, so I pass character by character. You see here, I enter a string. Special characters count, I'll initialize to 0. For every character that is present in the string is made up of A, B, C, D, E, means there are 5 different characters. I'm starting from A, B, C, D, E. I'm actually iterating through that. So what I try to do here, for each of the character in the string, first I calculate what is its Unicode. The logic is that if the Unicode is more than 127, right, we cannot come to a conclusion, but we can say that there is a chance of the character whichever you are seeing is a non-English character. Why we are not directly declaring that this is non-English? Because sometimes people give names where smiley is included in that. Okay, there may be a smiley. So in such cases, right, I write, say, A, B, C, D, E, then I give a smiley to that. Does it make the word I have written is non-English? Can you say like that? No, you cannot say. Because only because of the presence of smiley, I cannot say that, I cannot neglect that A, B, C, D, E, which is present in my text, and I cannot declare that as a non-English word. So you have to have a technique that, what if there is a special symbol such as, right, a smile. So for that, we keep increasing the count. If at all I see this, I will say that keep increasing. Okay. And it has been observed that if the count of the special characters is greater than 50% of the string, then that means, right, the whole sentence or the whole word that actually has been entered, or the complete string that has been entered into this particular function is not English. So see, the return false. All right, then otherwise, if this condition is not satisfied, return true, saying that yes, whatever string you have passed is English. Let us directly see whether this logic works or not. Okay, only when this works, I can say that yes, I have written a right code. So just look at this. I'm saying that in the Play Store data, this is not function. Okay, that there's a symbol tilde, right? It actually says that not of. In the sense, 0 comes, you make it 1. 1 comes, you make it 0. It's a not gate, if you remember. So not of Play Store data app apply is English, because whenever you say is English, what are the possibility of answer? Answer says false. or true. It will say yes or no. Now I am saying that I want to see what are the non-English apps present in my whole database. Not if you want to print non-English, I have to find out what are the non-English here. So that's why I'm complementing. If I say Play Store data, if I simply pass the Play Store data of that particular column to this, it will say yes or no. Whichever is no, I want to print that. So not of not is true. That's why you see here, there is a not written here. Not of this whole thing being not of not is what, right, comes here. So you see the names here. Can you see we were just identifying this by just looking at a column called app. Look at the app column, right? Everywhere you can see non-English. Though you see some of the English characters coming in picture, most of the letters are non-English. That's why it declares it as a non-English. All right, so yes, our logic is working, and this is how you can detect that. So you see, right, a question that somebody gives you a data set and ask a question like, do something like this. You have to explore what is the logic, right? For the logic purpose, definitely you can go to the internet, but then you understand the logic, try to write something like this. So see, only, right, the function you need to write is like hardly 8 to 10 lines of code. Then calling that function is pretty much straightforward in Python, and you'll get the answer right like this. Okay, I hope no doubts. Stop me if you have doubt at any point of time. Right, so I'm filtering this out. Okay, so the filtering out happens very straightforward. Now I'm not using the not here now. You see, directly I'm saying that only retain which say yes. In the sense, is it English or not? I ask every time. Whichever it says yes will be retained now. Okay, and I'll check the shape now. Now you see, out of 10,000 and odd rows, now we have only 8,175. Okay, next is that 10,000, right? If there is a million term M over there, multiply that whole number by 10,000. If it already is K, that is 1,000, multiply that by 1,000. So this is what we are supposed to do. Okay, so this is the code. Play Store size or Play Store data of size. So that's actually size is a particular column, is equal to the same size, and I need to apply a lambda function. What is a lambda function? Wherever you see x, multiply, convert that into string of x. Okay, convert it into string x, and now when it is string, I can actually do a replace option. So whenever I say, right, a string function is being carried out, and I can do a string operation such as a replace. So replace actually says that I can do the replace operation with the varies with the device. If at all you have something called as varies with the device as you enter, convert that into not a number. And if at all you see that if varies with x, right, every x in x, in the sense everything, if you see there is a varies with x, replace that with not a number. Then let's go further. So this is again applying the lambda function, but in such a way that I'm trying to convert the m, and I'm replacing it with 10 to the power 6. Okay, and if the data set is something like having a k present over there, like such as 10k, right? What do? Right, you will put a 10 to the 3 over there for k present in the string. So once you have that, so I just have to take care of the not a numbers here, right? In the size, if you have a not a number, right, deal with that, and then convert everything into the float. As a type float actually converts any format into the format which you require. So in this case, I'm looking everything as a float values. Okay, so the first part of our question, there were 4 different questions. Yes, we have finished that. So this is now after this, we don't have any not numbers present, missing numbers present, non-English words are also removed, etc. Many things we have done so far. So let's move on to the next part wherein we'll try to understand, can I visualize? What visualization helps us in understanding about this data set? We'll try to find out. So find the number of apps in various categories by using appropriate plot. I have to bring a plot now. That plot should show that which category is a particular what do you call particular item, right? And I have to see how many are installed in that. How many are there in that particular category? So category wise. So for example, if it is related to automobile, how many apps are there in automobile? I am supposed to find out. Like that, find out the various categories present and how many apps are right present in that particular category is what I'm supposed to. Okay, so as you can see here, we are trying to use n unique to find out the number of unique entries in the category. So, right, whatever it repeats, you don't consider that. Without that, you try to find out there are 33 different categories in the Play Store data app, Play Store data, right? So, what are the various apps present in each of the category? You can see that there is the first one is family, then game, then tool, personalization, lifestyle, medical, dot 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 dot, all the way till the last one, which is beauty. So these are the various categories present, and the second column you can see that 1504, 831, 625, right, etc. Right, what are they? They are the right number of what you call. So they are the number of apps in that category. Okay, family category has 1504 apps in total. So in the next step, you can use values.index that actually creates an array of the various categories of apps. So whatever you see as the names here, they have been converted into an array. And I will call what is we are calling it as a pie chart. Okay, so I'll directly call the pie chart now. So just see what happens when you call the pie chart. I just will call that this is PLT because it's a pie plot present under the Matplotlib. We have imported that as a PLT figure, specify the figure size 10, 15. So it says that horizontally 10, vertically 15. So plt.py, counts of apps. What's the count of apps? This one. Okay. So we have that. Then we'll say labels equal to count of apps dot index dot apps. Okay, so index dot values. That's the labels. Labels in the sense these will be the labels. And I have the last part is plt dot. It's called as a plt dot show. So as you can see, plt dot show, it actually brings up a pie chart like this, and you can see it with it's very clear that family actually occupies out of the 100%, 21.5% of the apps belong to family, then 11.9% belongs to game, and the least one is beauty, which is 0.5%. Right, then the second part of the question under this category is explore the distribution of free and paid apps across different categories. So I want to take up a category. In that category, how many are free apps, how many are the paid apps? I want to see. So there is a hint given. You can use what is called as a stacked bar chart. All right, so what I do, initially I extract the free and the paid apps. It says that the paid apps are 538 and the free apps are 6484. So this is overall, but I don't want overall. I want in each category how many are free, how many are paid. So paid category is equal to paid apps to category dot value counts. So that actually creates that. Similarly, free categories, free apps of category dot value counts. So number of entries will be coming up into the free paid category as well as the free category. We just try to we inspect that. All right. So this says that these are the paid categories. So family has 142 paid apps, game has 74, and so on. Now you'll see that length of the free categories, length of the paid categories. Now you see, I will call what is called as the stacked bar chart. In the sense, I have one bar, above that I should have another bar. You can give a different color so that you can understand that the whatever it lies in the top is a completely different data. Right? So just see here. As we can see, I'll say that P1 is equal to PLT dot bar free categories of 10. I'm printing only 10. I'm not printing all the 33. That becomes a mess. We will not be having that much space over here. Anyway, when you run the code, please type it other value and you check that. Okay. So P2 is another graph. I'll say that PLT dot bar, right? IDX, paid categories. What are the values, right? Only the 10 values. Then what should be at the bottom? In the sense, whatever you plot here, something should be there in its bottom because I'm trying to plot one below the other. So whatever is plotted will be coming at the top layer, and whatever already plotted will come to the layer below. You just have to specify that bottom equal. I'll say that free categories. All right. So P1 and P2 will be printed over there, right? And X6 equal to, right, free categories of 10, rotation is 35. You see the rotation is 35. That actually can be seen here. Rotation 0, rotation 35, rotation 90, vertically written. Text will be completely vertical if you change it to 90 degrees. So now you see this is the 35 degree version of the results. All right, then you go to the next question. Represent the distribution of the app rating on a scale 1 to 5. So let me complete my explanation for the previous one. You can see there is a legend given here, free and paid. So in the graph, if you see a blue, this thing, it is a free. If you see orange color, that's a paid. So out of the family related apps, majority of them are free apps. Only a small portion is the paid app. So same thing repeats for each and every case. Okay, like this, you can do what is called as a stacked bar chart, which is one of the very useful chart. Okay, then we go for a histogram, which is called as a frequency histogram. I'm trying to say that how many apps are present and right, what are their distribution. You see here, so there are very less number of apps with the ratings 1 to say 1.75 and 2 to 2.5 is slightly higher. Around 3.5 is much higher. Most of your apps have the ratings above, right, 4 or something. 4 to 5, if you see, it's the highest. So how do you see that? It's actually, right, simply will bring a histogram. So if you remember histogram, right, in the previous section, we had discussed that in detail. So I just specify that, give me 5 bins. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, etc. So it has been divided in that particular fashion. And you can also visualize that by using what is called as a strip plot. So this is how the strip plot looks like. You can simply call the functions strip plot to visualize this function. All right, so then we'll move to the next question. It says that identify the outliers of the rating column by plotting the box plot category wise and handle them. So I have to go for a what is called as a box plot. So what is a box plot? What exactly it does? So you can see here. I'll just explain the box plot concept. On the right hand side, if you see, we have a box plot, right? So this is the box plot. How does it look like? You need to identify a box plot will be of this type. So this is a part of the box plot. Then the next part is just like this. So the lowermost line says that that's the lowest limit that is possible for the given data set. Then whatever that comes here, right, it is 25%. So it's called as a, you can call it as a Q1, right? The first quartile, the central value will be median. That's the central value of these two. Whatever you see, right, between them, you can call them at the center, whatever you have is the median value of that. Similarly, this is a quartile number 3, so you can call it as a Q3, and the topmost value is equal to right, upper limit, and anything which is outside this and this, right, between the two lines, we call whatever lies between the two lines, right, will be considered as the interquartile range. So you see here, what we try to do here is we try to define two different values. Okay, one is called as a upper whisker, one more is called as a lower whisker. So upper whisker is 75% value plus 1.5 times the IQR. Next one is 25% minus 1.5 times IQR. So take a difference between those two values, you get an interquartile range. Okay, so if you see this, this is the one which contains all the data without removal of the outliers. Now we'll apply this logic and we'll try to write a function called as outlier removal, right? So I just pass the data into this, and I want the machine to calculate data.mean, data.sv. Okay. All right. So the next part, we have written a code just this for that. You can see here, right? Lower and upper values are calculated. Data mean minus cutoff, data mean plus cutoff. So we have applied that same logic and we have calculated what are the outliers removed values. Outlier removed in the sense, whatever satisfies this condition. See, if you know the basics, you should be able to identify that this is called as a list comprehension taken directly from the fundamentals of Python. So whatever is remaining, we call it as an outlier removed data. Oh, and that data we'll be trying to, right, retain. Now, after you do this outlier removal, you can see that the data is going to look like this. So highest value, highest rating is 5, but the least rating has a value equal to 0, right? But we will not be using that. Okay, so you can see that it will be retained, but we will be considering this part of the rating, right? Okay, so previously the ratings were, look at the rating value. They looks like there are some outliers, but you see the rating actually was from 1 onwards. But after the processing, look at the data, right? Look at the rating. Rating actually comes to a different value. Okay, so that is the IQR, usage of IQR. Right, let's proceed further. Okay, there is another question saying that category wise, how many installs are there? Right, so you see game is the one which has the highest install. If you remember, game was not the one having highest number of categories. Okay, game category did not have many number of apps, but you see here, in spite of that case, the game has been installed by huge number of right installs compared to the other one. So for example, you see the gap between this much extra, right? So that comes to be approximately 9 into 10 to the power 10, because there's a 10 to the power 10 present. That's actually exists. That's a coefficient, that's a multiplier that exists for each and every installs over here. So that's the highest one. What's the second highest one? The family. And the third one is communication, and so on. Okay. So that is the part which actually uses the various types of plots to have a visualization. So now you see that we could understand certain concepts related to the data set, right? By doing what is called as the analysis part. Again, this is we are halfway through the analysis, right? Meanwhile, I just want to know if you have any doubts. We are performing the EDA of the Google data store data set, and so far we were discussing about uh, the various visualization, how the visualization is going to help us in getting a better insight of our data set. All right, so let's move further. The next concept is actually about uh, deriving more insights of the data sets. So there is a question saying that, does the price correlate with the size of the app? So what does it mean? Correlation means one of them increases, other one also should increase. It's called as a positive correlation. When one of them increases, other one decreases, it's said to be negative, right? So just above this, I have skipped that part, but here you can see the same explanation. You get this material, please go through this in detail, you will understand. Okay, so as the price increases, if the size decreases, negative. Okay, negative correlation. So the question is that, is there any relationship between the size and the price of the app, right? So normally we should understand that there is nothing to do with the size and the price. So if that is the case, the one particular file which is too huge should be having very high price for that. That's not going to happen. Anyway, we all already know that, but I want people to justify that by visualizing something. So what we do, we'll try to make a plot. So in this plot, right, you can call that as a LM plot. So if you try to plot that, I'm saying that X is the price, Y is the size. Okay, so convert that. And I actually have made a small modification here. In the price.str, L strip, in a sense, dollar, whatever that there is, because it's a price, right? So you have a dollar present over there. Again, this data set says every value is in dollars. So I want to remove the dollar symbol from that, because that, anyway, it's a symbol, it doesn't convey the price for that. So we are stripping that out. That's what happens in the first line. And the second one is that, right, the price is converted into float value. Okay, even if it is not float, it will get converted into the float because of this particular statement, right? Then I'm saying that price is along x-axis, size is along y-axis, right? The data is the complete data set, which we call it as a Play Store data, right? And show me the graph. You can see there is no relationship like that, right? Whenever it is very less, I already have, right? Everything is arranged in one corner. I don't see a straight line somewhere, right? Saying that if X increases, Y also increases, you have a positive slope. If X increases, Y reduces, you have a decreasing slope. So straight line should be like this. That is, one increases, other one comes down. So you have a decreasing straight line, otherwise increasing. I don't see that. Okay, so it's simply scattered all over around. So there is no such correlation. So you can see, we can conclude that no particular pattern increasing, decreasing. So, right, there is no such things happening. All right, so that's one thing. Then go to the next question. Now you see, we are actually in a different level of question. Previous set of questions were completely different. They were very simple. Now you see, we have to do 2-3 kinds of analysis to get into this. Find the popular app categories based on the rating and the number of installs. So rating should be high as well as the install should be high, so that you can call that it is a famous category. So how do you do that? You look at this command. I told this is very important, right? When we discuss the pandas, this is why I'm grouping that by the categories. So I want category names to come first, then do an aggregation, correct? Aggregation in the sense, installs, take a sum, rating, take a sum, category wise, do this. Then just do the sort values of rating in the ascending order. I'm doing the ascending, then I say reset my index, in the sense, otherwise, right? Because each of the categories will have different indices, right? So now I don't want them to be in the original index format. Starting from 0, 1, 2, 3 only I get. So I'll do the reset index part. Now you see family comes first now, because after ascending, doing this in the ascending order, whatever resulted here is showing them. So this is the most famous one now, according to this rule. Family is the most famous. Games comes next. Tools, personalization, and medical, because it says that find the popular this thing. You can go, you can even do the, you can try to go with the 10 or 15, right? So I have written head here. If you write a 10 inside this bracket, it will show the top 10. Okay, right. Now, based on the number of installs, if you want to say, that will be game. But if you want to talk about the rating, that will be family. So that's what is the conclusion that we have written over here. Okay, so you can do your own type of analysis and you can come to this conclusion. All right, then you see again we have done this, but right, group by the category, right? Rating, we are taking the mean of that, not the sum. So if you take the mean values of ratings, then you see events becomes first, art design next, education, then see, depends on what is your view, right? What exactly you want to consider as your standard. According to that, the results will change. So previously I told I would like to consider the sum of the ratings and the total number of installs are what I want. Now you see, I change this to, I want the average rating of an app, particular category. In that case, this completely changes. Okay. Go to the next question. How many apps are produced in each year category wise? Correct. So make a piece, make a slice of your year. Starting from this year to this year, you can do something like that. Again, one particular example I have shown here, right? So what we are trying to do, I'm looking for the last updated column of that. Okay, so last updated column, right? If you go till -4 means starting from 0, starting from the last, come 4 units backwards. That means you are considering the year. So look at which year you are talking about, 2010 to 2018. Now look at a particular year, any year you can take, because it says that year wise you can do that. So again, I have given answer only for I think 1 or 2. You can repeat this for other years also. Year wise, what happened? Which of the category, right, got installed, right, by what amount in which year is the question. So there are which, what, when, many questions are there. So 2018 will take that. Okay, so in 2018, right, year equal to 2018, I'll check that. So I'm trying to write, right? It's a count plot in the sense you measure the count, Q equal to year, a particular year, and category wise I want to. X-axis is category. You can see the X-axis that has been plotted over here, right? This actually talks about various categories. Categories, this axis is a count, and this data comes from a particular year. So again, you can come to a conclusion that the family has been installed more than 800. Okay, and next is the game. This is the picture of 2018. Move ahead, do the same thing. Now you see family is more than 350, then game is around 150, and there is another category, tools, that is also approximately very much close to the games. Like that, this was the question. Year wise, show me what happened in each of the category. So you can do the analysis in this particular fashion. So the plot that you are using here is called as a count plot. Okay, next. Identify the highest paid apps with the good rating. There has to be a good rating and highest amount of, it should be a paid app, not a free app. So what we do, this is how we try to analyze. You have to fit a rule here. The rule that we are going to fit here is equal to, so app with rating equal to or greater than 4 is what we are going to consider that as a good app rating. So more than 4 should be the case. So you see, we put multiple conditions here. Play Store data of data rate dot rating should be more than 4. In the column rating, I should have more than 4. Now you may say that, no, I don't say to 4. I want it 4.5. Just change this, greater than or equal to 4.5. Then it says that it should be a paid app. So type should be paid. And not only that, I want to put it in the ascending order. Okay, sort values by price, ascending equal to false, which means descending order. Then you can even put the reset index if you want to be in the order 0, 1, 2, 3, 4. But anyway, we have not done that. Because of that, my indices are not starting from 0. So top rated, top 7 apps are what we are seeing here. So you see, don't worry about these numbers because we have that just represent the original row number or the index in the original table. You can reset if you require. Otherwise, you see, right? So you can see that price is 399, rating is 4.3, right? And other values are there. So I am rich pro. So those are the app names, right? Name of the app, which category it is, what rating you have, what reviews you have, etc. Many things are there. So this is the highest one, 399. Okay, dollars. Okay, then what are the top rated apps? I think we are trying to find out the same thing over here. Okay, so the next question, are the top rated apps are genuine? How about checking the review count of the top rated? Is it possible to count? Because you may see that we try to find out the top rating by a particular what you call rule that I have defined. Now I should try to justify that. I selected this as a top app. Reviews also should support that. That's why we have this question coming up. Are they genuine? Right? Will you be able to justify that it is, yes, this is the top rated app because of what you're trying to do now? So this is how it goes. We'll try to call it as a top rated, right? So Play Store data, the rating should be equal to Play Store data rating max, right? Whatever max rating you have and Play Store in the whole Play Store data, whatever rating you have, compare them. Whichever says they are equal, extract them into top rated. Okay, give them index now, NP arrange 0 to the total length. So there will be, right, a length which is created. So I'll convert them into int and I'll show you the reviews, top rated of reviews. How many reviews are there? We are trying to see them now. So you see 329 has 15, 612 have 5, 615 has 2, like that. Now, if you try to visualize the same thing, right? So from this, you can see that which category it is, what is the rating given, right? How many reviews are there? Same numbers. You can see 15, 2, 2, 2, etc. So 15, 5, 2, 2, sorry, 15, 5, 2, 5, 6, etc. That's a review count, right? So those apps which have the rating equal to 5, I can see here. Now it is left to you. How do you decide whether it is a genuine reviews or not? Okay, maybe you may have to check for the ones which have been installed, right, by the authentic installation or simply giving the ratings or something. You may have to use any method, right, that you like, that you say that it is correct, and you can try to go with that. Okay. Now, again, as the next part of our analysis, we'll go for what is called as a distribution of review count for top rated apps. Okay, so for a top rated app, right, index of the top rate versus the reviews I'm trying to plot. So you see here, the y-axis is the top rated of reviews. Reviews is this much, right? On the rightmost side, you can see this is the amount of reviews, right? And along this axis, right? So we have the index. So starting from 0 to, there may be around 250, I think 275 apps that are present on the top list. So the review count, you can see the review count is pretty much less for the ones which are at the top. So topmost, what do you call, entries of the list you just now created, saying that these are the top rated apps. As you come down, the rating reduces. But you see, the topmost apps have very less count. Correct? The number of ratings are very less. Maybe because of even the same thing happens in Amazon or Flipkart. You go and check that, you search for something, maybe say anything you search, say formal shoes. Then you go to the options and select top rated, right? And in the top rated, you may have an option that say 4 and above. But when you click 4 and above, you think that this is the highest rated thing. But if you observe the number of reviews written over there, that will be just 2, 3, 4, 5, just something like that. That's what is happening here. Same thing. Okay. So our analogy, whatever we have applied here, is the same thing which matches with the what is exactly happening in the industry side. Okay. So that's why I said that this is a very practical way of doing the analysis. Okay, so like that. So frequency distribution is what we have been seeing here, right? And let's try to look at the density distance plot, right, of the same thing. How many of them are, right, having a rating equal to highest rating? So you see that, right, very close to the 0th level. In the sense, you have the highest thing that is happening very close to 0. In a sense, on the top of your list, whatever apps you have, they are actually saying that they are the highest rated apps. Okay, so then, sure, let's move to the next question. If the number of reviews of an app is low, what could be the reason of top rating? So the same question, reviews are not there, but our algorithm says that this is a top rated app. What could be the reason? Top rated because it is free. So how do you identify that? Okay, so apps below, right, review 5, top rated of the reviews being less than 5. So total that top rated, whoever has less than 5 will try to take that. Now, free apps with that value is equal to this. Then the paid apps below that, right, using this condition. You see the condition changes is either free or false. Free or paid. Right. Now you try to print here. So you see that 129 of them are free, 20 of them are paid. So the answer that we may say that, right, they are free, right? That's why their rating is high. So it's same thing. Again, you observe something. Go and search, say, formal shoes, right? You will see that whichever you opt for more than 4, rating is more than 4, right? User reviews are more than, rating is more than 4. If you search that, it will show a list, okay, list of items satisfying your condition. Maybe you can even select, you don't talk about any price, right? Don't talk about price. Don't say anything for the price. Price range, leave it blank. And at the end, right, when you come back to the product, you'll see that they are of cheaper price range, right? So the same thing. Anyway, they cannot give the product for free. But here, yes, in this scenario, yes, they can give the apps for free. So now the conclusion is that since the apps are free, yes, they are, right, considered to be the top rated items. Okay, same thing is happening over there. Because they are cheaper compared to all the other products, they have been given a top ratings, though their, they have got lesser number of reviews. Possible. Okay, so this is how we can try to do an analysis. All right, so go through the document when you receive it and come back to me with doubts. Definitely we'll discuss and we'll proceed further.